Hi everyone. Okay, so I hope you guys can. I hope you can hear me. Sorry about the delay. There was some technical glitch, but I think we have now sorted it out. So we will get started with this session. Let me just give you 1 minute to sort of settle down because we started a little bit late. So in case somebody is not in front of the. Hi everyone. Okay, so now here's the deal. So what are we going to do today? So today I'm going to talk about the chapter on reflection and refraction of light, which is in your class 10 CBSE curriculum. Okay. Now, unlike the normal way of teaching, today I'm going to teach in a slightly different manner. Okay. So, two things. One is we are going to go a little deep into the idea. So, I want to test how well you have understood even some basic concepts because 90-95% of the time we do not understand uh, things that we take for granted. So I'm going to make sure that you have very solid grasp of concepts. That's number one. Second thing is, I'm going to teach you by asking you a lot of questions. So there'll be obviously I'll be teaching you, but my focus is going to be in helping you think. So you come up with the answers, right? And I will help you. So together we'll figure out the answers. Okay. So shall we get started? Okay. So let's do that. So okay, guys. So now let's start with some basic stuff, right? Um, so first thing is, um, what I'll do is go through with the basic ideas pretty quickly, and then we'll spend some time on things which are really interesting. So let's start with this very quickly. This one I'll go very fast because you already know. So first question is, how does light travel? So you know that light travels in a straight line. That's not a surprise, right? Second thing is, let's say when light is, so let's say there's a ray of light. Okay, there's a ray of light going like this. If the ray of light hits something, so let us say we have a mirror. Okay, so here we have a mirror, and I didn't draw this nicely, so let me draw another one. Okay, so here we have a mirror, and this is the side. No, this side is not reflecting. This side is reflecting, right? So now when this ray of light goes, what is going to happen? So this ray of light is going to get reflected. So this line that I'm drawing, this line is called normal. Why is it called normal? This line is perpendicular. It is perpendicular to the mirror. So this angle is 90 degrees. Okay. So when you have a line which makes an 90 degrees with any particular surface, we call it normal. So this is called normal. Okay, normal. Now the question is, what happens to this particular ray when it hits this surface? So what do you think? Now, pretty straightforward. You know this, right? So the way to think it, the analogy would be, let us say if this was a wall, okay, and if you threw a ball, what would happen to the ball? The ball would essentially come like this, right? So this ray also follows a similar. It's got a similar behavior. So this ray will get reflected. Let me use a different color. The ray will get reflected like this, and this angle, if this angle is, let us say, I, and this angle is R, then I is going to be equal to R. One more thing, while I'm teaching, I will follow a slightly different way of learning, which is that I don't want you to take notes. Okay, once again, do not take notes while I'm teaching. I will give you some time to take notes, and I'll tell you how to take notes. Okay, then you can start taking notes. So now you may just focus on the teaching. That will make it very easy. Right? Now, if I have to just draw this neatly, let me just draw it a little more cleanly. So now let us say I have, this is the mirror. Oops. Okay. And if a ray of light is coming from here, this is a ray of light, and if this is the normal, then the ray of light will get reflected, oops, in such a manner that this angle I and this angle R, right? So this I is called the angle of incidence, and this R is called the angle of reflection. Okay, this is the angle of incidence, angle of reflection, and the first law of reflection says that I is equal to R. That's all. Very, very simple. Right? Then there is one more law of reflection. What is that? The second law, which is that it says that the the incident ray, the normal and the reflected ray, they all lie in the same plane. Okay. Now let me explain what this means. So I'll just move to my camera so I can explain this to you a little better. Okay. So I want you to see me now. Okay. So when we say incident ray, reflected ray, and the normal, they lie in the same plane, what does it mean? So let us say this is the surface. Okay. Now if the ray of light is coming like this, it will get reflected like this. Okay. But it is so the normal is going to be like this, correct? Yeah, normal is going to be like this. So if the incident ray is like this, comes like this, it will get reflected like this. What it's saying is they are all, the incident ray, the normal, the reflected ray, they are in the same plane, which means they are in the if I take a if I take, let's say, a flat surface, right? All three of them, they lie in the, they are in the same, they are on the same flat surface. It's not going to be like, the ray comes like this, and after reflection it goes like this. That won't happen. Okay, this is essentially the idea of, this is the second law of reflection. Very, very simple. So I'm not going to spend too much time. So two laws. Okay, one law is angle of incidence is equal to angle of reflection, and second is that the angle of incidence, the normal and the reflected ray, they all lie in the same plane. Now I want you to take a minute and take notes. Now here is how I want you to take notes. First thing is, the way you have been taking notes in the school, that is not the right way to take notes. So we follow a very different system, which is that I would like you, after every like 15-20 minutes, 10 minutes, I'll give you some time, and I want you to think. Okay, think about what has been taught, and then from your understanding, you write it down in your book. If you are getting confused about something, you can look at the screen. I'll put the screen before you. You can look it up, but never, I repeat, never copy from the screen directly to your notebook. Do not do that. Okay, look at the screen, understand, and then write it in the book and do it in your own words. Okay, this is the most important thing that I want to teach you today, other than reflection of light. Okay, so now let me just switch to the screen. Okay, and here we go. So here's the screen. Now I want you to take half a minute and just write down. So the first law is that angle of incidence is equal to angle of reflection. Yeah, this one. And second law says that the incident ray comma normal and reflected ray are in the same plane. Okay, now write it down very quickly, and after this, so this is just basic revision. After this, it will become very interesting. So I'll just give you 1 minute to do this. Okay, take your time. टिंकू सिम्बा इज बॉदरिंग मी, जरा उसको बुलाओ वहां पे. Okay, excellent. So now this will get more interesting. Okay. So next question I have for you is, uh, you have been told, and this is something that this is something that you may remember from previous classes. You have been told that when there is a plane mirror, okay, I'll draw this. So when there is a plane mirror, so this is a plane mirror, right? Now, if there is an object here, I will take, let's say, this red dot. This is the object. The question for you, in fact, I'll ask you the question. This mirror, okay, this mirror, so so this is the polished side. Okay, so light falling coming from here will get reflected in this direction. So the question for you is, if this is the object, where will the image be formed? This is what I want you to think and tell me. This is the object. Okay. So the question for you is, image, right? Where is the image formed? What do you think? Okay, so let me now discuss this. So the image is formed. You must have learned that the image is formed behind the mirror. Okay. Now this is something which a lot of children, they have heard this, but they don't fully understand. So what we are saying is that if this is the object, the image is going to be formed behind the mirror, right? But what does that mean, and how does that happen? So today I'm going to make it very, very clear to you. I'll spend about 10 minutes on this, because no yes, so what you guys are saying is correct. It's formed behind its equal distance. So the question is, how is it equal distance? Why do we know that, and what does it mean to say image is formed there? So now I'm going to clarify a lot of those concepts, and I'm going to go back to some basic ideas about what an image means. So let's start with this. So now let us say here is, right, here is an animal, right? Now let's say if you are here, right, if you are here, you can see this cat, right, or whichever animal this is, right? Now let's say if I'm just talking about the eye of the cat. Okay, by the way, don't worry about the size. I know the man is small, cat is big. Don't worry about all that. Okay, we're just trying to get some basic ideas straight. So let us say you can see the eye of this cat, right? Now there is one more person here. He can also see the cat's eye. Maybe there is one more person here. He can also see the cat's eye. So if both these people can see this cat's eye, what does it mean? It means that light is going, light which is getting reflected from this eye, right? It is going in all directions. So some light is going and reaching this person's eye, some light is from here is reaching this person's eye, and so on, right? So which means that lot of rays are going out, right, are getting reflected from the eye, and that is why different people are able to see the eye. This is one basic idea. Second idea is that, let us say now we'll just take the eye, or take one object. So let's say this is a point object, and now understand this very, very carefully. Okay, this is very, very critical. So now let's say this is an object. Okay, now if let us say here is a person, and this is the person's eye. I'm drawing the eye very big. Right? Now what happens? Now from here, let us say rays of light are coming. So there is this one ray of light, and there is this another ray of light. Right? These are the two rays of light. Now this person whose eye is here, this person can see this object. So this person says that the object is here. How is eye able to see the object? So what you're doing is, the rays that are coming, when you look back, if you project the rays back, they meet at this point. So wherever the rays meet, right, for this eye, that is where the object is. Once again, very carefully. for this eye, let's say these are the two rays which are coming, right? For this eye, the rays which are coming to the eye, wherever, if you extend them backwards, wherever, at whichever point they appear to be emerging from. Okay, so these two rays, they appear to be emerging from this point. So for this eye, this is the object. Okay? Now the reality is that if, let us say, there was no object, let's say there was no object here, right? But if the rays of, if the rays of light were coming like this, what would the eye know? The eye does not know there is an object. So this eye would still say that the object is, this eye would still say that the object is here. Okay, whether the object is here or not, the eye does not know. I can only see these two rays coming at it, right? So whenever the rays which are coming at the eye, if we extend them back, wherever they meet, that is where the image is formed. This is one basic idea, and I'll tell you why this is very interesting. Now if I take a plane mirror, okay, let's do that. Let us now look at a plane mirror. Okay, so this is a plane mirror, and now let's say there is an object here. Okay, now from this object, multiple rays of light, I'll just take two rays. So I'll take one ray of light which goes like this. What will happen to this particular ray? It will follow the laws of reflection. And what does the law of reflection say? It says that if I draw this normal, the light will get reflected in this manner, such that this angle and this angle, they are equal, right? So this is one ray of light. Okay, now let us say if I take one more ray of light which goes like this, right? What happens to this? This also will get reflected. How will it get reflected? So here also I will draw a normal, right? And this light will get reflected such that this angle of incidence will be equal to the angle of reflection, right? So this is going to be one. So I've taken two rays. Okay, I've taken two incoming rays. So this is my ray number 1 and ray number 2, and after reflection they come like this. Pretty straightforward. Now here is a very interesting part. Okay, this is a part that is never taught and explained in schools, and we never understand why do we say the image is formed behind the mirror. That I'll explain to you now. Let us say your eye is here. Okay, now let us say this is your eye. I'm drawing a big eye, right? Now when this light is coming from here, remember what we mentioned here, when the rays are coming, the eye does not know the object is not. I will say, okay, wherever these rays appear to be coming from, that is where the object is. If I apply the same logic here for this particular eye, what will the eye know? I say this. So this eye will, or the person whose eye is here, that person will say, where is this object? He'll not say object, he'll say, look, extend them back, and wherever they meet, that is where I see the object. So if I now extend them back, okay, if I now extend them back like this and back like this, sorry, let me draw this nicely. Okay, so now as far as this eye is concerned, for this eye the object is here, but the object is not here, right? Sorry, the object is not here, object is here. So this looks exactly like the object, so we call this the image. Okay, so this is the image, okay, and this is the object. And the core idea is that, I'll repeat, that when eyes looks at any object, right, then when the rays of light are coming, wherever the rays of light, if we extend them backward, wherever they appear to be emerging from, that is the point where we will say that is where the image is. And now here the very interesting part is what you guys also said, which is that if I do that, I'm not going to do the full trigonometry and all that, right? But these angles are equal. So if you look at this triangle and this triangle, they are congruent triangles, and this distance is D, and this distance is also D. Okay, D is from here to here, this is D, and from here to here, okay, this is D and this is D. And now we can say that, oh, okay, now we can say that, look, if this is where the object is, the image is going to be formed behind the mirror, and the distance is going to be exactly the same. I'll stop here for a minute or so, and I will do two things. One is I will now give you time to take notes, and this is, I'll just repeat this one. You need not take any notes, but you can just, this basic idea is that rays of light are going in all directions wherever somebody can, wherever a person can see. That is why you're able to see. There's a, this multiple people are able to see this cat because the rays of light are going in multiple direction. This is the thing that I want you to draw in your book, which is that when an object is there, then the rays of light are going. Even if the object is not there, I will always say that okay, object is wherever the rays of light appear to be emerging from. Right? So object appears to be where the rays, where the incoming rays appear to be diverging from. Okay, so this is for an eye, right? So when an eye looks at looks at any object, right, the object appears to be, and this wherever it appears to be, right, where the incoming rays appear to be diverging from, and this is what we call an image. This is, so here in this case, this is the object, right? But if the object was not there, like in this particular case, since the for this eye, the eye sees the object here, but since the object is here, this is not the object, so this is called the image. So this is the basic idea. Now I would like you to take a minute. Do not copy from the board. Think, take your time and just write it down in your notebook. And whatever questions you have, you can ask on the chat. I can answer. Okay, one question. In the plane mirror, image is always imaginary, sir, isn't it? Okay. So we won't say image is imaginary, but what you're saying is correct. But we say it's a virtual image. Okay. So it's a good point. So I will mention here that this image, it's a virtual image. Why is it a virtual image? Because it's not like the image is actually formed there. Right? Here, I have to extend them back geometrically to get this. You can't. It's not like I can put a screen here and see the object. In fact, there is a mirror. There is no light going here. Right? So this image is called a virtual image. So you are right. Let me know when you are done with the notes. Okay, so one question is, why do we extend behind? Right, good question. Right, so Ashok, let me explain. See here. By the way, you should be asking these questions because this is where our understanding will get better. In the classroom, we always just take it as a given. Here, I don't want you to do that. I want you to be asking these questions. Okay. So now, why? Okay. So now, why are we extending it backward? Right? So as I explained once again, if the object was here, listen to me carefully. Okay. If the object was here, then the rays of light would go like this, right? So where would you say is the object? You say the object is here. How do you get that? You get it because you say the object is here because the rays. How do you get this object? If you take the rays and extend them backward, wherever they meet, that is where the object is. So the point I'm making is that even if the object was not here, as long as the rays are coming here, I cannot see I does not know where the object is. I only knows the light. So from light, from the direction of the the rays, it will say that the object is wherever the rays appear to be diverging from. This is the basic idea. I hope this is clear to you. Ashok, please confirm if this is clear. Okay, so now we have an excellent question from Shweta, which is why do we have to take two rays and not one? Very good question. So Shweta, here's the answer. In fact, you could also ask the question, why do we take two rays? Why not three? Why not five? Why not 10? Right? So I am going to now explain that question. Okay. So yeah. So let's say uh, let's say there is, if we just draw, so this is an object, okay, and an eye is observing here. If I draw, so first of all, how many rays are, let's understand, from basic principles. I don't want to just give some formula and some theory, and we should actually understand from the basics, okay. So fundamentally what's happening here, what's happening is that how many rays are emitted from here? Infinite number, right? There are infinite number of rays which are emitted by any object. That is why a person here, all anybody at any of these positions can see the object. Okay, so first point is infinite number of rays are emitted. Okay, let me clean this up a little bit so you'll be able to see this carefully. Okay, now uh, now second question is, now let's say if I draw to find where the object is, if I draw just out of all those rays that were there, if I draw, let us say, just one ray, okay? Now where is the object, right? If I just draw one ray, I cannot find where the object is, because the object could be here, or the object could also be here, object could be here, object could be here, it could be anywhere, right? But once I have the second ray, once I draw the second ray, right, then I know that object cannot be here, object cannot be here, object cannot be here. These two rays are meeting at this point, so object has to be here. Remember, we are not saying only two rays are coming. We are saying, look, lot of, so it's like this, let us say in your house, someday, uh, you're waiting for, let's say, result of a cricket match. Your TV is not working, and your friends come and tell you that, let's say India won. Now when one guy says, you are not very sure is right or wrong, but when two guys says, okay, this is okay, India has won. But now even if 5 or 10 guys come and say, you still know that, okay, India has won, right? So that is why we need two rays, because two rays will tell me exactly where the object is. But after that, we don't need more rays. We can draw, there is nothing, no harm. So let us say, as an example, I could draw one ray like this, I could draw one ray like this. But the point is, uh, but the point is, all of them would be, any two rays that I take, they'll appear to be diverging from the same point. So I don't need more than two rays. Two rays are enough, and one ray is not enough, because one ray can come from any of these points. Okay, so ray diagram is essentially just a way of saying, okay, where is the light coming from? So Shweta, is it clear? Just let me know. Okay, so while we are awaiting answer from Shweta, anybody else, any questions, you can keep asking me. Okay, very good. Now, okay, everybody has taken notes, I'm assuming. So I'll just move forward. If anybody has not taken notes, you should tell me now. Okay, now we are going to start something. I'm going to start an interesting topic, which is, um, in fact, I'm going to ask you a lot of questions, right? And we will figure that out through the using those questions. Okay. So first question is, mm, what is a spherical mirror? I mean, I'm sure you must have heard of it. So what is spherical mirror? So I want you to think for a few seconds. Okay, so now let me explain to you what a spherical mirror is. So let us say I take a sphere. Okay, so I okay I take a sphere. Okay, here we go. So now, uh, actually, let me do one thing. Let me redraw this. I don't like the sphere. I'll delete this. I'll draw a fresh sphere. Okay. Uh, okay. So I'll draw a sphere like this. Right? Now, let us say I take a knife or something. Okay, and I cut out a portion. Right. So I cut out a portion like this. Now what happens? Now I got this part of the mirror. Can you see this? Yeah. So this mirror that you see here, right, this mirror, it is not a plain mirror. It has got a curvature. It is bent like this, right? And this mirror can be considered to be part of this bigger mirror. Makes sense, right? This mirror, you can think of it as part of this mirror. Okay. Now, because this mirror has been derived from a sphere. Once again, because this mirror has been derived from a sphere, it is almost as if it was part of a sphere. We call it a spherical mirror. Very, very simple idea. Okay, so we call this a spherical mirror. Makes sense, right? Okay. Second thing is, any sphere has got some property, right? What is the main property of, like, how do you specify? How do I tell how big the sphere is? Somebody asks you, like, what is the size of the sphere? How will you say what is the size? You will say the radius is so much, correct? So which means that this sphere is going to have some radius. Let us say r. Right? So this r is the radius of the sphere. Now here, if I have only a part of the mirror, right, we call this r also radius. But since we don't have a sphere, we can't say radius of sphere. We'll say radius of the curvature. Once again, the same r. Okay, the same r. I'll draw a line. So they'll take the center, draw a line from here. So this distance r I take, right? So this distance r, with this r is called the radius of curvature. It is the radius of curvature. Okay. This is the basic idea of a spherical mirror, and this is a side from which it is coating is done, and this is the side from which light will reflect. A very, very basic idea of spherical mirror. So I have introduced. Let me just give you a couple of other terms also. This point at the center, okay. This point at the center, what is it called? It's given a name. We call it a pole. Why is it just a convention? Okay. So this point is called this point, we call it a pole. Another thing, this line which is touching the pole, and it is perpendicular at this particular point. If I were to draw a tangent, okay, at this point at the pole, if I were to draw a tangential surface, this line is at 90 degrees to this tangent, and this line is called principal axis. Okay, so these are, okay. One more thing I want to tell you. This, if you look at this distance, okay, the distance from here to here, right? This length, it is called aperture. From here to here, this length is called aperture. Okay, I'll just give you a few, maybe like half a minute or so. I want you to write these down. Okay. Once again, do not copy from the screen. Take a look, understand. There's no rush. Okay, take a look, understand, and then you write it down. Core ideas, I'll repeat. A sphere, a sphere has a radius. If we cut a part of it, we'll get a part of a, this is the mirror which is part of a sphere, so we call it a spherical mirror. The center point is called pole. If I draw a line which is perpendicular to the tangential surface at the pole, this is called this line is called principal axis, and the distance r is the distance of the from the center to the pole. It is called the radius of curvature. So just get these things done, and then I'll ask you some interesting questions. So Jayan has a question, why we call spherical mirror. So Jayan, as I explained, it is called spherical mirror because it is a this can be considered a part of a, see, it is bent like this, right? Since it's bent like this, we can think of it as it can think of it as part of a sphere like this. Actually, this is a sphere, right? So it will be part of a sphere of this particular size, and therefore we call it a spherical mirror. So Jayan, please tell me if this is clear. Ashok has a question. Radius is constant in this mirror. Okay, maybe I did not understand the question. So okay, let me say this carefully. See, for a given sphere, right? There is a, for this particular sphere, r is constant, right? So for a given shape, once you tell me the shape, I can tell you what is r, right? If I change the shape, so let us say as an example. In fact, a question for you. I want you guys to think and tell me. There are two mirrors. Okay, there are two mirrors. One mirror is like this. Okay, another mirror is like this. Okay, this mirror is A and this mirror is B. Which mirror will have a, so this mirror has got a radius of curvature. This has got a radius of curvature. I'm calling it RA, and this has got a radius of curvature which is RB. My question for you is, which is more? Is RA more than RB, or is RA less than RB? Which is correct? Think and tell me. I will come to Nishad's question in just a few seconds. Let's first get this one. Correct. Very good. So Jayan has the right answer, and it's very easy to understand, right? If I use a different color, right? If I were to complete this circle would be something like this. So its radius is going to be this much, whereas this one is going to be a very big circle, right? So its radius is going to be probably something like this, maybe even more, right? So this is going to be your RA, and this is this distance, right? This is going to be your RB. So as you can see, RA is greater than RB here, right? That is the basic idea of. So the question that you asked was, which is somebody asked if the radius is constant. So radius depends upon how much is the curvature. If it is bent very mildly, once again, if it bent very less, if it is curved very less, then RA is going to be large. If it is curved a lot, right? If the curvature is very high, then the radius is going to be small. This is a basic idea. Another question which one of you asked was, what is a concave and convex mirror? So that's my next thing I'm going to explain to you. Right now, here I once again. So let's do this. Let us draw a. Okay, so this is a sphere, right? Now I am going to let's say cut a portion from here, okay, and this is my mirror. Now I can do one thing. I can, okay, done. So now there are two mirrors, okay, and okay, here we go. Now what I can do is, one mirror I take and I paint it from this. I put a I put some silver from this side. So here, this is the side which reflects. Okay, so if a light comes like this, it will get reflected here. But in this case, I am going to paint from this side. Okay, so I am going to put some silver coating from here. Okay, such that this side is reflecting. So here, light comes here and come like this. Here also, this is reflecting like this, right? So here, this is called concave mirror. This is called a concave mirror, and this is called a convex mirror. Okay, the way to remember this is, the way I like to remember is, imagine, like, let's say you are seeing from here, right? What does it look like? This looks like the mouth of a cave, right? So the word concave has got cave here, right? This is just a way to remember. This is not how the name has come. Just an easy way to memorize. So this looks like the mouth of a cave. So this is from this side. So so therefore remember that this we can call this a concave mirror, and the opposite, the other one, is going to be convex mirror. Okay, make sense? Okay, so if there are any questions you can ask, but I'm just going to move forward. Okay, thanks, Molly. So you have confirmed. So now I'm going to ask you a question. Okay, now you have to think. I'm not going to give you all the answers. Right? This is it's a group study. We are all learning together. So I'm going to ask you another question. What is the question? The question is this. Okay, and we will spend some time. So don't worry. We'll go very, very slowly, and we will try to understand this. So let me first again draw I will draw a concave mirror. So let me first take a sphere, and let me just cut a portion of that from here. I have this here. Now I don't want the sphere, so I'm going to delete this. So now I have a concave mirror here. Okay. Now this is the center. So this is the pole. I'm going to write here P, and I will draw a line. Didn't come out well. I'll draw it again. Okay, much better. This line is my principal axis. Okay, so this line, this is the principal axis. Now here's a question, and I'll give you time. I'll not give you the answer. You have to think and tell me. Now let's say first question. Let's say there's an object. Okay, there's an object which is some point object, right? So object was, let's say, here, and then I sort of move the object behind. Okay, I move the object and now bring it here, then I bring it here. I'm moving this object from here to farther away, right? So first question is, the rays of light coming from this object, as I move the object from here to here to here to here to here in this direction, the rays of light that are coming from here to the mirror, right? how will they change? Like what will change about those rays? I'll give you a hint. Okay, I'll give you a hint. So hint is this. Let us say if an object is here, okay, the object was here, then the rays would look like. So let's say I'll take two rays from here, right? One ray which goes like this, and one ray, let's say, which goes like this. Okay? Now these two rays, there is some angle between them, right? And the angle is pretty high. Now if the object is moved from here to, let's say, here, right? So now the object is, let us say, here, and then in next case I move the object here. As the object is moved from here to here to here, what happens again? Let's say there are two rays coming to the same point, right? So from here there is one ray which is coming from here, and there is one ray which is coming from here. The angle between them, if you look at this angle and this angle, which angle is more? Think carefully and tell me. If this angle is, say, A and this angle is B, which is more? A is more or B is more? Think and tell me. Is A greater or B greater? Type the answer. I want to see your answers. Very good. Excellent. So, from Joe's answer is A is bigger. Absolutely, A is bigger. Now here's the next question. Okay, Jayan says B is bigger. No, Jayan, think about it again. Right? Is B bigger? B is smaller, right? I'll just draw it. I'll draw it nicely. So let's say here. Okay, one ray like this, one ray like this. Okay, this is point A, and this is, I'll take a very far off point. Right? From here, if I take one ray, oops, draw it very carefully, one like this, right? And I'll draw from here one like this. Okay. Now this angle and this angle, which is more? This is A, this is B. Now you can see, right, that A is greater than B. Correct? Makes sense, right? Yeah. Okay. Now next question. This is a very, very interesting question. Okay, because I'll show you something, which I'm pretty sure you would have never. You would probably have in the classroom. It may not have been explained. So you must have heard that they say when an object is at infinity. You must have heard this. When an object is at infinity, the rays coming in are parallel. Everyone says this, but very few children are explained why that is the case. I'm going to explain it to you now. Okay. Now let us say this object is the previous one, right? When I move the object from here to here, let me change the color of the pointer. Okay. Now when I move the object from here to here, what happens? The angle becomes smaller. When I move to here, the angle of these two rays coming will become smaller. If there are two rays, so if I keep moving this object, behind, what will happen? The angle will ultimately become 0. Correct? Makes sense, right? Now here's the question for you. The question for you is, if there are two rays, okay, if there are two rays and the angle between them is, let us say, this angle is become smaller and smaller, what's happening between what's happening to the two rays? They are almost becoming parallel. Once again, let me draw this and show it to you. If, let us say, there are two rays and the angle between them is very, very small, this angle is very small, okay, we can see that these two rays appear almost, just look at this here, right? They appear almost parallel. So when the object is at infinity, object is extremely far, then this angle will become 0 and the rays will become parallel. And that is why we say that when object is at infinity, the rays coming in are parallel. This is the reason we say this. This is a very important point, but is never explained in any book properly. So I wanted to make sure you understand this, because after this, I'm going to build on this. Anybody has any doubt, you can ask me. I'll give you 30 seconds. Any doubts, you can ask me. Remember, as the angle becomes smaller, the the rays become sort of parallel. Okay, that is the idea. Have you all understood? So which means we can say that if I have, let's say, a convex mirror here, sorry, concave mirror, right? And if the object is very very far, so let's say this is your principal axis. If the object is very far, right, then all the rays coming in are going to be parallel. This is the point that I want you to understand. Is this clear? Yes or no? Tell me so I can move forward. Okay, good, excellent questions. Thank you for asking this question. So first, so let's start with Shweta's question. Shweta says, "Sir, what does it mean by when object is at infinity?" So Shweta, what it means is the object is very far. So let us say here, this has got a radius of curvature. Let us say its center was here, right? And this radius was, let us say, 100 centimeters. Okay. Now, if you have an object, let us say, uh, which is so this is 1 meter. Now, if you have an object which is, let us say, 50, say 20, 30 meters away from this, or 50 meters, right? Then, for all practical purposes, we can say that it is at infinity. So, when you say infinity, it doesn't mean it has to be like, farther away from sun, moon, and Jupiter and all that. It just means that it is much larger than the object distance is much greater than the radius of curvature. So let me write this: infinity object at, let me actually write fully, object at infinity. It means object distance from mirror is much much greater than the radius of curvature. That is what it basically means. Okay, couple of other questions. Uh, Meena Anil, sir, can you please say it one more time? Meena, can you please tell me which is the portion you want me to explain? I'll do that. Meanwhile, Jayan says actually distant objects radiate light in every direction. So Jayan, the answer is, see, any object which is shining, right, or which is reflecting light, it will be reflecting light in multiple directions, right? So a distant object, um, it's not about distance. See, light will be reflected depending on the shape of the object, right? Let's say there is a on front of the in front of the table before you. Let's say an orange is kept on the table. Now, now let's say you are sitting, you can see the orange next to you. Let's say your father or brother or mom or dad, they are sitting. They can also see the orange. So which means the light is going in multiple directions. Even an object which is not very far off from you. So that it doesn't have to be distant for light to be reflected in every direction. Okay. Okay. Now I would like you to take notes. Okay. And what are the notes? So basically, the point is that, first of all, what is a concave and convex mirror? Points you have to note down. Right? What is a concave and convex mirror? Second, I want you to understand why, when an object is at infinity, the rays coming in are parallel. Why that is the case? These are two things that I would like you to note down. Okay, this and this. Take your time. Thank you, Shweta. Thanks a lot. Okay. Um, Meena Anil, I did not understand this. I'll explain this again. Okay. Um, Others, you can take notes. Meena Anil, I will just explain this for you again. See, um, others also can watch. Okay, because if she has a doubt, you might also benefit from this. So, so let us say there is a mirror here. I'll draw a small one, right? So there is. Let me draw this a little nicely. Okay. So let's say there is a. Okay, I'll do one thing. I will actually first draw a small circle. From there, I will take a. Okay, so this is our mirror. Okay, now now let us say I have an object. Okay, there are two objects. Okay, one is a red colored object, other is a yellow colored green colored object. The red colored object is here. Okay, and the green colored object is, let us say, here. Now the light coming from the red colored object, right? Let us say the light coming, we are looking at light coming at these 2 points. These two rays are coming like this. These two rays have some angle between them, right? But if when the object is very far off, what happens? Just watch. This is uh, I'm explaining this for Meena. Others also can understand, right? So when the object is very far off, let me draw the principal axis also. When the object is here, now if I take the two rays of light coming here, see there is one ray of light like this, right? Another ray of light which is coming like this. So, so, so Meena, if you just look at this portion, okay, look at the look at these two green rays, right? So you can see that they look almost parallel. Is it correct? Because this point is very far off. Now, if I increase the distance further, they'll become more and more parallel. Makes sense, right? So if this distance is infinity, let us say it is like 100 times the radius of curvature, and these two would look almost parallel, which means that when an object is very far off, we can assume that all the incoming rays they'll be uh, they'll be parallel to each other and parallel to the principal axis. So what I will do is when we do the diagrams, and this is very important, when we do the okay. So uh, now let us say when I say that an object is at infinity, right? When I say object is at infinity, then uh, then the rays of light coming, what I'll assume is that the rays of light coming are going to be parallel. This is the assumption. I'll not be drawing these long rays. I will actually skip out. I'll skip all this whole thing. I'll just say that when the object is infinity, the rays of light are parallel. This is what I've been trying to explain. So let me know if this is clear. Any doubts? You should let me know. Okay, a couple of other questions I'll take. Which of these images can be formed by convex mirror? So Jayan, I did not understand your question. If required, you can give me a call after this session. I can explain to you one-on-one. Maybe I'll be able to understand this better. Okay. Joe's one question: principal axis pass through pole and perpendicular to the plane. Correct. That is right. Okay, all of you have taken notes. Please confirm. If you have taken notes, we can move forward. Okay, now let me just check. I'll give you 5 seconds. Let me just make sure that everybody is following. Give me a. Is it streaming or is it buffering? Okay, so now before we finish, I'm going to ask you one or two more interesting questions and then we'll wrap up. Right? So, now here's a question, okay, which is, let me just make sure. Okay, now next question is, um, let us say I have a, let's say I take a concave mirror, okay, so I'm going to take this part. This is a concave mirror, and we will get this. I'm going to, this is the pole, and now I have two questions for you. Okay, so think carefully and tell me. Now let us say there are, an object is at infinity. Okay, object is at infinity, which basically means object is very far from the, very far from the mirror, and now there are two rays of light coming. Okay, so there is, so let's say there is one ray of light coming like this. Okay, and there is one ray of light, oops, okay, so there are two rays of light coming here. Now the question is, uh, what will happen, and let's say this is, there's one ray of light coming along the principal axis. So 3 rays of light, right? Now the question for you is, what will happen to each of them after the reflection? Okay, each of these 3 rays. So I'll give them a name. Okay, I'll give them a name. I'm going to call this A, B, and C. What will happen to A, B, and C after reflection? So think about it for 5 seconds and then tell me. So easiest one is B. First tell me B, what will happen? What do you think? Okay, guys. So there was some. Sorry, I had muted myself. Sorry, I forgot to unmute this. So now I have drawn. What I've done for you is I'm asking you a question, which is that now let us say I have drawn a. So here I have a concave mirror, and there is an object which is at infinity. Okay, object which is at infinity, and the question for you is, now this object, there are rays coming from this object is not here, by the object is very far off. Okay, so the rays that are coming, they're all parallel. I have taken 3 rays. Okay, A, B, and C, and these 3 are all parallel, and this is the pole here, right? So when 3 rays come, what will happen to them after reflection? So let's first start with B. B is the easiest. So what will happen to the ray B? This is pretty easy, right? What will happen? So this ray comes like this, and it goes and it will get reflected right back. Okay, so which means after reflection, it will just go back like this. But what happens to the rays A and C? That is what I wanted to think. So first question, if the ray A goes like this, after reflection, will it come back like this or will it change direction? And the answer is it will change direction. Why? Think and tell me. So if you think about it, right? So let's say this was just user intuition. Let us say if this was a wall and you were throwing a ball like this, what would happen to the ball? The ball would come a little bit in this direction, right? Why is that? Because at this point, right, at this particular point, right, if I draw a normal, right, it would be something. Sorry, if I draw a tangent, it will be something like this, and so the normal is going to be something like this, right? So which means the ray will get reflected. The ray will get reflected such that maybe it will come something like this, right? Similarly, this ray also would get reflected and it would come to the same point. In fact, I have drawn only 2 rays. I could have drawn any number of rays, right? I could have drawn 1, 2, 3. I could have drawn like 1 more, 2 more, 3 more, here. All of them would get reflected and they would come to the same point. Now this I've not proven it to you. I've just shown it to you. Okay. But right now in class 11, they will be able to do the derivation. Right now, I can just give you the basic idea. So all these rays would, after reflection, they would meet at the same point. Okay. Now think about it. All the parallel rays, they are coming to the same point. So what will we call this point? Think about it, right? All the rays, all of them come back to the same point. So we can say that all these rays are getting focused at this particular point. Okay, we can say that all these rays are getting focused at this particular point, and this point is called focus. Okay, so what does focus mean? Focus is the point where parallel rays meet after reflection. So I'll just write it for you. So focus, right, it is the point where parallel rays meet after reflection. Okay, so remember, only parallel rays will meet at focus. If the rays were not parallel, right, then they would not come to focus. But this is the property of a concave, or in fact of any mirror, right? After reflection, the rays will meet or appear to meet at a point which is called the focus. Okay, and one last thing I'll tell you here is that the distance between the focus and and this distance is called the focal length. So let me just write this. So this distance, right, this is P. I'll call this, let us say, F. So FP, this is called the focal length. Is something showing on the screen or is it all blank? Then let's end this session. Tell them that we'll cover this. And just type it here. Just say that there's some internet quality issue. We will resume and we'll start from wherever we left off another day. Internet problem. Should I disconnect? No, should I end stream now because people are typing comments?